All right, example 3. Going to change things up a little bit now. We have a function that its a value is not greater than 0. This a value is between 0 and 1. Another way to write this would be f of x equals 1/2 to the x. And that's the way you'll see it more often, probably than 0.5. But notice in this case, a is still greater than 0. A does not equal 1, but in this case, a is between 0 and 1. That's different than our last two cases. The last two cases that we had were 2 to the x, 4 to the x, and in this case, a was greater than 0 for both of them. A did not equal 1 for either of them, but a was larger than 1 for both of them. A was 4, a is 2. What we have now, and this is the same, just written differently, a is still greater than 0. A does not equal 1, so it's still an exponential function, but a is less than 1, but greater than 0. So we're getting a decimal in here. Okay, so that's what we're dealing with. So let's choose some values of x. How about -3, -2, -1, 0, 1, 2, 3, and 4. Now we've got to do some thinking here. Our base value is 1/2 to the -3. The negative means flip the base. We learned that in the previous lessons. So it's 2 over 1 to the 3, which is 8. 1/2 to the -2 is 2 to the 2, which is 4. 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is still 1/2, or 0.5. 1/2 squared is square the top, square the bottom. It's 1 over 4, which is 0.25. 1 over 1/2 to the 3 is 1 over 8, 0.125. And 1 over 2 to the 4 is 1 over to the 16, which is half of that one. So let's start plotting some of these points. -3, 8, -2, 4, -1, 2, 0, 1. That keeps showing up because whenever that exponent's going to be 0, the whole thing's going to equal 1. But then we go to 1 and 1/2, or 0.5, 2 and 1/4, so half of a half, 3 and 1/8, so half of a quarter, and 4 of 1/16, so half of 1/8. Let's try plotting these. 1, 2, 3, 4, -1, -2, -3, -4. And -3, 8 might be one of the easiest ones to plot. So -3, 1, 2, 3, 4, 5, 6, 7, 8. Let's put it here. So that'll be -3, 8. -2 and 4. 1, 2, 3, 4. -1 and 2. 0, 1. So we see that we have this curve that's now shaping this way. Okay? And as we come around here, 1 and 1/2, half of a half, half of a half of a half, half of a half of a half of a half. Obviously I can't keep drawing that, and obviously there's always a half left over, so we're getting this asymptote idea, getting closer and closer to this horizontal axis, but never crossing it. So let's notice what's happening here. As x gets closer and closer to positive infinity, as it goes that way, the y is actually approaching 0. So it's getting down and down. And as x is going this way, as x is approaching negative infinity, going this way, we notice that the y value is going up and up and up. So, what's the domain and range? Well, x is an element to the real numbers again. The range, y must be greater than 0 still, and y is an element to the real numbers. X and y intercept. No x-intercepts. Y-intercept, 0, 1. By the way, 1, 1/2 was here. That guy in there is 0, 1. So the y-intercept always. Intervals of increase or decrease, that's what we have here. So you can say that y is increasing when x approaches positive infinity. Or, another way to say that, oh no, y is not increasing as x approaches positive infinity. Sorry, y is decreasing. And we say that y is increasing when x is going the opposite direction. Any asymptotes? Well, the asymptotes will be the horizontal axis here. So it'll be the x-axis, which, given an equation, is y equals 0. So in summary, if a is a decimal between 0 and 1, we're going to get a function that looks like this. It's always going to have a y-intercept of 0, 1 still. It's still always going to have this horizontal axis as an asymptote. And as x approaches positive infinity, you're going to get y approaching 0. It's getting closer and closer to 0. And as x approaches negative infinity, you're going to get y approaching positive infinity. It gets larger and larger. Okay, ladies and gentlemen, I think that's it for me. You got some questions to do, and we'll talk to you soon.